Remember that when we were solving the photography problem, that we made a visual representation of this quadratic function, which represented the area of the photograph. This was our visual representation of the problem, where S was the amount being cut off left and right, and 2S was the amount being cut off top and bottom, and this was what was left for our photograph. And the problem asked us, when is the photograph 54 square inches? And we found the answer to be S equal to 1.5. But we tried all our boundaries and we found that at least S could be 0. That meant we had cut away the entire mat board, and we were left with a photograph that was the entire size of the mat board, or 144 square inches. We came up and it got smaller and smaller, the photograph that we could get in. And at the end, we could only be left with the whole mat board, which means we did not cut anything away, and our photograph was 0 square inches. So this was a visual representation of the photograph problem. What we want to do here is make a mathematical representation of it. We want to make algebra here, graph here, and tabular here. So let's see what that means here. What does this visual thing here mean mathematically? Now, when we put in a function in GeoGebra, we always use the variable x, and also by convention, capital A is a point, so we're going to use f of x. So click down here in the input bar, f of x, our function is of x, equals 144 minus 72 times, and now we're going to use x because that's what GeoGebra needs for functions, plus 8 times sx squared. No worries if you try to put s in there, GeoGebra will complain. Let's hit enter, and we can see something was drawn here. We can't quite see what it is. So we know that we want between 0 and 3, and we can see that that's this part going right up there. So the first thing we want to do is kind of find out where it's gone. So we're going to press shift and go on the y-axis at the very top and drag it down. See if we can find the function. There, it's coming down, right? There we go. And we can see that it's always positive, which makes sense because it's a physical problem. So let's shift and drag this over down into the positive and make the part of the function we're using fill up the screen. Notice that the scale on the y-axis is larger than the scale on the x-axis. This is the part of this function that we're interested in, when x goes between 0 and 3. And what we want to do is restrict this function to just this interval. So just this piece of the function is what we want to be looking at. Click down here in the input bar, g of x equals, and now the GeoGebra command for restricting is function. We start typing fun, there it is, go between the brackets, and now we tell it we want it to use f of x as our base function, but only to show it between x equal to 0 and x equal to 3. So we're going to restrict f of x to those values. And it's hard to see it, but you can see it's a little bit thicker there. Let's make it a little bit better. Right click, object properties. We'll move it off so we can see it. Let's make the color a dark red, and let's make it thicker. There, we can see it. And we don't even need to have its label if we don't want to, so let's turn off the show label. And that's it for that. So come back over here, close. This is the piece of function that we're interested in. Let's put a point on this function. To take our point tool and click on G. So we're probably going to get both, so we choose G. And now that's very light colored, so we're going to change its color and we're going to make it show coordinates instead of A. Now, this is a GeoGebra tip. We're going to turn off this view so that we don't get these pop-ups like this, where it says point A. So we're going to turn off the algebra view. And the next thing we're going to do is we're going to take this point and click and drag it down to a whole number value, like 30. What was 30, by the way? That means when s equals 3, let's go over here. How much area did the picture have? 0, right? So this is showing that. And what we want to do is now click on this, make it glow. See how there's a little glow around it? Just click once. Now we're going to use our arrow keys to move the points. So we're going to use our left arrow key, and then it will go by 0.1. So let's see, at 2.5, it says when S is 2.5, the area of the photograph is 14 square inches. Let's see, 2.5, the area is 14 square inches. We've cut off 2.5 from this side, 2.5 from this side, so we got a total of 7. And then we'd cut off double from this side, so 5 here and 5 here. So we're only left with a height of 2. 7 times 2 is 14. Okay, let's go back to this one. Just click up here so you can continue to use your arrow keys. Let's go to our answer, which was 1.554. There it is, 1.554. So this piece of function is all at once giving us all the different things that we saw over here visually. And we get some information. We can see that as S increases from 0 to 3, or X increases, the area of the photograph decreases. What was its maximum area? Let's use our arrow keys. We get the 0.0144. So when we cut out everything, our photograph has to be 144 square inches. Now, how would we solve our problem with just looking at this piece of graph? We see that the photo is 54 square inches. So that would mean that the function has to be 54 square inches, or the y value has to be 54 square inches. So we're looking over here at 54. We would go to the right and then come down and say, oh yeah, that's 1.5. But how do we do that precisely? We come down to the input bar and we say, let's draw a horizontal line, y equals 54. And then we can see that the place where 54 intersects our function at 1.5 and at 7.5. Do you remember those two values? When we substituted 54 inches and solved the quadratic equation, those were what we got. Let's find these two intersection points. So go to the intersect tool and intersect between the line and the function. And we get 2 points. Let's get them labeled with their coordinates. And we can see 1.554, which was valid because it was in the purple part, and 7.554, which was not valid because there was no way to cut out 7.5 inches from both of these sides out of a 12 by 12 piece of mat. So we see that by drawing y equals to 54 square inches and finding the intersection points, we were also able to find the solution. Okay, how about a table of values? So let's say we want x here and f of x here. We can't write x, we have to write double quote x double quote and enter. And then over here we want to write double quote f of x double quote. Okay, so that's our label. We're going to start with 0. Right, our first value is going to be 0, and we want to calculate the function value here for A2 for this cell. So we would write equals f of capital A2. And we should get 144. Everybody agree? There it is. Okay. Now, let's make our step size 0.5 so we can get them all here to up to 3. So we want to add 0.5 to A2 now here. So equals A, capital A2 plus 0.5. And we want this one just to be copied down, right? And that should, let's see if we get that. If we were to take our point here and move it to 0.5, there it is, 110. Okay, now we're ready. We can just go down to where we get 3. If we get a little bit too much, we'll come back and erase them. We got too much, so let's erase these rows here. So I mark them and I delete them. So here we have a very small table of values, which we could of course make bigger by making a smaller step size. So here is how we've done visualization of the problem. We'll turn the algebra view back on. Here is our algebra of the problem. Here is our function view of the problem. And here is a table view of the problem.